Hey guys, I'm going to go over using the antiderivative, or the first fundamental theorem of calculus, to find the area under a curve. So you should be able to determine the area under a curve, and I'm just going to use a power rule for antiderivatives. You should be able to find the area under the curve using an antiderivative, but only for the power rule. So let's take a look at a couple examples. So let's say I have this curve here, and I'm interested in finding the area from 0 to 2 under this curve. So the area that's under here. Now, this area can be found by using Riemann sums, and you've done that. You should have done that in the past already if you're taking calculus. If not, this is a pre-calculus intro. One of the ways we use integral calculus is to find area under the curve. And we can find area under the curve using something called an antiderivative. And an antiderivative, if you remember from the power rule, so if I was taking a derivative, okay, y equals x squared, if I took the derivative, I'd have y prime equals 2x. Well, an antiderivative is going the other way. So instead of bringing the 2 down and subtracting 1, I'm going to divide by the number and add 1. So if I had, I'm going to call this f of x. If I had x squared and I wanted to do an antiderivative, and a lot of times for antiderivatives we make it a big F, okay, big F of x. Antiderivative, I'm going to add 1, so 3, and then divide by that number, 3. So that if I took the derivative, and sometimes we put a constant here, but I'm going to show you what we're going to do today. We're not going to need that constant. If we took the derivative, okay, this is big F prime, right? The derivative of that is going to be, we're going to multiply with 3. The 3 is going to cancel, subtract 1, we're going to get 2. So this is our function, and our antiderivative is going backwards. So to do the antiderivative power rule, we're going to divide, we're going to add 1, then divide by that number. You can think of it as this, x to the n plus 1 over n plus 1. Okay, so this is how you find the area under the curve. The area of the curve is given as an integral. Okay, this is called an integral. Integral from a to b, and a to b would be where we're looking at finding our area. So a to b of f of x dx. And that's going to be defined as the antiderivative of b minus the antiderivative plugged in with a. And so we're going to find the antiderivative, and then we're going to plug in b and a, and that's how we're going to find the area under the curve. So for this example, I'm going to have the integral from 0 to 2. Those are called our limits of integration. So we're going to go from 0 to 2, because that's where we're finding the area, of x squared dx. And the dx stands for a differential. It means the difference, and when you get into calculus or you've done Riemann sums, it has to do with the rectangles we're taking here. Okay, so it's just a notation that we're going to use. So this is our function, and that's our notation dx. Is equal to, and what we're going to do is we're going to take the antiderivative. Now we just determined that the antiderivative is x cubed over 3. And what I like to do is make a little line here and say I'm going to go 0 to 3, so I know I'm going to plug in 3, and then I'm going to plug in 0. So I'm going to plug in 3 first, like f of b. It's big F of b. So I'm going to have 3 cubed over 3 minus, plug in 0, 0 over 3. Okay, 3 cubed over 3 is going to be 27 divided by 3. So I'm going to have 9. Okay, so I have 9 units squared. Okay, so that's the area under this curve. Let's take a look at another one. Let's say I want to find the area down here. Now what's going to happen is when we do our definite integral, we're going to end up with a negative because this area, this region, is below the x-axis. So we're going to go ahead and set this up. The integral from 0 to 3 of x squared minus 3x dx. So we're going to take the antiderivative. So we're going to, again, we're going to add 1 and divide by that number. And then we're going to do the same thing here. So we're going to add 1, which is 2, and divide by that number. Okay, and we're going to take those from 0 to 3 because that's where we're going for the area. All right, so we're going to plug in 3, and we're going to get 3 cubed over 3 minus 3 times 3 squared over 2 minus, put this in parentheses, 0 cubed over 3 minus 0 squared over 2. Well, that stuff's all going to be 0. 0. Okay, so what do we got here? We got 3 squared over 3, which is 9, and 27 over 2. All right, so let's do a little bit of fraction work here. 18 over 2, 27 over 2. 18 to 27 is 9, so we're going to have negative 9 over 2 square units. Well, you know, like I said, our answer should be negative because we're under the x-axis. But if I'm looking for the area, then the area is going to be 9/2 units squared. Well, we'll say square units. Okay. Okay, so that's it, guys. All you do is take the antiderivative, square roots. What am I doing here? Square roots, square units. You take the antiderivative and you plug in the values. That's the second fundamental. That's the fundamental theorem of calculus. We're using definite integrals. We're using integrals to find the area under a curve. That's it.